So in this scenario, we have a toy car with a mass of 2 kilograms. Horizontal surface with no friction at a speed of 1 meter per second. Car collides with a vertical wall. So here's our wall. The wall applies a force of magnitude 20 newtons. So it's going to apply a force this way. F equals 20 newtons. And since our positive direction is by convention to the right and negative to the left, this force will be minus 20 newtons. And it applies it for a delta t of 0.2 seconds. Which of the following predicts the motion of the car immediately after the collision? Well, what we know is that there's going to be a change in momentum experienced by the car. And we know the momentum of the car beforehand is mv, so we have 2 times 1, and the momentum is 2 kilogram meters per second. Now we have this impulse, j, which is equal to the change in momentum, which is f delta t, and so we have minus 20 times 0.2, which is minus 4 kilogram meters per second. So that's the change in momentum. So if this car starts out with positive 2 and ends up with minus 4, then that means afterward it's going to have a momentum of minus 2 kilogram meters per second. So if it has a momentum of 2 kilogram meters per second, there's some things we know. We know that it's in the opposite direction. And if P equals mv, and the speed was 1, the mass stays the same in this case, which is 2, then we know that the velocity is going to be minus 1 meters per second, and the speed will be 1 meter per second. So those are the things we know from that situation. Now, the speed of the car will increase. Well, no, the speed will be the same, 1 meter per second and 1 meter per second. Speed will decrease. No, speed will remain the same, true, and the car will travel in the opposite direction. Well, that is what we seem to think is going to happen. We think that's our answer. The car will stop and remain motionless. No. For that to have occurred, the change in momentum would have need to be minus 2, but it's actually greater than that. It's not only that impulse is not only enough to bring it to a stop, it is large enough that it causes it to change direction and move in the other direction. And so that's why our best answer is choice C.